Good day everyone, you're welcome to my YouTube channel. Today we have the following problem. Integral as x is going from 2 to 4, x raised by 2x open bracket 1 plus the natural logarithm of x close bracket dx. At the first glance at this question, I was thinking maybe this question would be very difficult because of this time I'm seeing x to the power x, okay, which has no elementary solution. But this problem is very simple and easy, and I'm going to show you guys the easiest way to solve this problem, okay? Now let's try to manipulate this x raised to 2x. So what do I mean? This x raised to 2x here can be written as x raised to x, okay, times x raised to x. Okay, now let's see what the function will look like when we rewrite this x raised to 2x in this form. Okay, so we have now this to be integral from 2 to 4. Okay, now x raised to x, as we know, times x raised to x, then open bracket 1 plus the natural logarithm of x dx. Okay, now the question still looks like a beast from here, but not really that. Okay, now let's think of when we let this function here x raised to x. So let's think of when we let this x raised to x equal to u. So when we differentiate it, what are we going to get? So now let's go to the derivative of x raised to x. Okay, now we're going to do this derivative using the product rule. What is this product rule? That when we have to differentiate two functions like this, f of x, then g of x prime, okay, is equal to f prime of x, okay, g of x, then plus g prime of x, okay, then f of x. Okay, now let us say y is equal to x to the power x. Now taking the natural logarithm of both sides, so we have the natural logarithm of y is equal to the natural logarithm of x to the power x. Okay, you know the rule of this logarithm, so this x moves like this. Okay, so we have the natural logarithm of y is equal to x times the natural logarithm of x. Now differentiating both sides, so we have here, okay, dy all over y, that is to differentiate this, is equal to, you know, using this, so we have x prime times natural logarithm of x, then plus natural logarithm of x prime, then times x. Okay, now we have dy all over y is equal to, in bracket, differentiating x with respect to x is 1, so we are left with the natural logarithm of x here. Okay, now plus, you know, to differentiate this natural logarithm of x is giving us 1 all over x, so we have here from this place when we differentiate this, so we have x all over x, and that is equal to 1, so we have 1 here, then dx. So dividing both sides by dx, okay, and then multiplying both sides by y, now we are getting dy dx, okay, is equal to, you know, y open bracket natural logarithm of x plus 1, and don't forget that y is equal to x raised to x, so we have x to the power of x, then open bracket 1 plus natural logarithm of x. Wow, and this is exactly what we are seeing here. So this is exactly what we are saying here. So we can easily take this substitution, saying let u equal to x to the power of x. Okay, now we all know du is equal to this x raised to x, that is to differentiate this, then open bracket 1 plus natural logarithm of x, okay, then dx, and that is exactly what is here. So whenever we see this x raised to x, open bracket 1 plus natural logarithm of x close bracket dx, so we're going to substitute it using what? Du. So now this integral is becoming, so we are having now integral. Now remember that the limit is going to change, so now when x is equal to 2, that is, we have 2 raised to the power 2, so u is approaching 4. Okay, when x is equal to 4, that is u equal to 4 raised to the power 4, so u is approaching 256. Okay, now x raised by x is our u, so we replace it with u. Then x raised by x, open bracket 1 plus natural logarithm of x, close bracket, dx is our du, so we replace that with what? Du. Wow, this is very beautiful from here. So we have this to be equal to, u raised to the power 2 all over 2, then from 4 to 256. Okay, now let us see how we're going to simplify this. Okay, now this is equal to, now 256 raised to the power 2 all over 2, okay, minus 4 raised to the power 2 all over 2. You know what I did? 256, when u equal to 256, so we have 256 raised to the power 2 all over 2, then minus the lower limits, 4 raised to the power 2 all over 2. Okay, now we all know that 256 is the same thing as 2 to the power 8. Okay, 256 is the same thing as 2 to the power 8. So now when we rewrite this 256 as 2 raised to the power 8, remember the exponents will become 16 because of this 2 here. So we have 2 to the power of what? 16 all over 2 minus 4 is 2 raised to the power 2. Now we have 2 raised to the power 2 inside bracket. So the exponents, new exponent will be 2 times 2, that is 4. So we have 2 raised to the power 4 all over 2. Now using the simple indices law, we all know that because we have this base and this number here, they are equal, so we are going to subtract 1 from the exponent. So we have 2 raised to the power 15 minus 2 raised to the power 3. Okay, now factor out 2 raised to the power 3, so we have 2 raised to the power 12 minus 1, I mean, so minus 1 here, so that is what? 2 raised to the power 3, then 2 raised to the power 12 minus 1, and this is equal to what? 2 raised to the power 3 here is 8. Okay, open bracket, 2 raised to the power 12, as we all know, this is equal to 4096. Okay, minus 1. Now we have 8 open brackets, 4096 minus 1 is 4095. So when you multiply this together, so we are having 32, okay, 760, and this is the required answer to the problem. Thank you for viewing. Please make sure you subscribe to my channel and share my videos. Thank you. Bye bye.